the fireball will head directly for our planet, it would be the greatest catastrophe of all, the biggest fireball ever to hit our Earth. And I have already seen a preview of this event, and it certainly will annihilate many, many nations.
Calculations prove to be correct. This will be the most frightening discovery of all time. These two bodies have traveled almost 1 million miles in 2 weeks.
The night sky, a huge empty blanket around the Earth. And above all, a symbol of peace and tranquility. But what if someone told you that out there, a rock, big enough to wipe out the human race, was heading for us? They would be joking, wouldn't they? This town has a strange history. It has twice encountered extraterrestrials.
I just thought, I don't want the neighbors to hear about this.
It was a very, very strong force that penetrated the house.
We heard this tremendous crash, and we looked up and saw this huge hole. We could see the stars, and
we just looked at each other and asked a very intelligent question. I asked Wanda, and she asked me, what happened? It came through the ceiling of the living room. It bounced from there into the dining room, which was adjacent, hit the ceiling, rolled, and hit the ceiling a second time, then ricocheted off to the east wall of the dining room.
and then rolled underneath the dining room table where it was found by a young fireman, one of our volunteer firemen who came to the house after our call.
Matter of fact, we celebrate each year. We get together for a dinner each year. There are 6 of us.
On the anniversary.
On the anniversary. So it's been an important event in our life.
A unique experience for the Donahues, but not for Wethersfield. 10 years before, another rock fell out of the sky on this house, only a kilometre away. No other town can boast this.
At cocktail parties, we have something to talk about. Nobody can top it.
So rare are meteorite falls that enthusiasts can be driven to the ends of the earth to find them.
It's a very tedious job indeed, and when the weather is very hot, it can almost drive you mad. You have to concentrate very hard, you clear your mind of everything, you look on the ground for hour after hour after hour, and focus your mind on small, dark rocks.
Fingers crossed. I'm going to find a big one as well.
Main thing, not to go wandering off without letting anyone know. Always have a water bottle with you, but mostly never go wandering off on your own.
In most parts of the world, your chances of finding a meteorite would be pretty slim. But here on the Nullarbor, they're very high. Here, it's been dry for tens of thousands of years at least, probably much longer than that. It also has a general lack of vegetation, and the local country rock here is made of limestone, a pale rock. Most meteorites are very dark rocks, and so show up against a pale background. They're more easily recognized here than in most other places. Meteorites have been accumulating here for a long time, tens of thousands of years, and so that they are concentrated on this ancient surface that we're walking along.
All the rocks on Earth have been processed and altered by volcanic activity. But meteorites are different.
Meteorites are a unique source of information about the earliest history of the solar system. Some of them have chemistries which are very similar to the chemistry of the sun. And clearly these are very primitive objects indeed.
Among those who study rocks from space, some now believe they have a much more sinister relevance to life on Earth today.
I hate the thought of us behaving like ostriches and stuffing our heads in the ground, pretending that there are no potential dangers around the corner. The reality is that these fireball increases will happen fairly suddenly when they happen. We have no means at the moment of predicting them. They may happen tomorrow, they may happen 100 years hence, who knows? The fact is, we do not, as a society, as a world society, have the means of handling this situation at the moment.
These grim warnings seem strange, given the benign appearance of fireballs. This one was spotted last year, all the way from Canada to Texas. More of a natural firework with a bit of a bang at the end.
Michelle Knapp's car is like a museum exhibit. Hundreds of people have been coming by since Friday to look at the hole in her trunk. What damaged her car was this rock. Already, she says, she has had several calls from museums and collectors wanting to buy it and the trunk of her car.
Unfortunate for Michelle, but hardly something that should panic society. Rather a thrill for the collectors and a spot on local television.
Mr. Drewcott, what were you doing at the time? I went out the back of our house, and I heard the bang.
Oh, they were so excited to think that it was a meteorite.
And we hope that members of the public will help us by looking for these.
I'm inclined to wish now that it dropped on somebody else's garden, not mine.
Could it actually have been anything else, like an unidentified flying object or a spacecraft?
That is an unanswerable question.
Above all, society is skeptical nowadays. Ideas of death and catastrophe from the sky belong to ancient times, before the age of science, when superstition made people petrified of the heavens.
They clearly saw the sky as interactive with the Earth, and originally the broad idea was that there were things impacting upon the Earth. God hurled his thunderbolts at us, and there were catastrophes.
Catastrophism ruled. The heavens were seen as a source of wonder and potential global disaster. Then came the Age of Enlightenment, and all this was to change. First, Isaac Newton explained, through his theories of gravity, the motion of the planets. And then his friend, Edmund Halley, correctly predicted the return of a comet, which was subsequently named after him.
The picture that emerged was clearly the one that Newton himself was picturing, where the solar system was seen as a giant clockwork machine. And the image was that this clockwork would function forever and forever.
The new philosophy of science took a uniformitarian approach. It argued the Earth was billions of years old and reasoned its formation must have been unimaginably slow.
And this idea hadn't been truly accepted by perhaps the church and clerics, many of whom still thought that the biblical record implied catastrophe. The whole of this argument came to a head in the middle of the 19th century with an argument between Bishop Wilberforce and Huxley, which Huxley won. And this was essentially a victory for science over everything. And it was science with catastrophism written out of it.
Turning our backs on our superstitious past, catastrophes were laughed out of mainstream science and banished to the realms of science fiction. By the time this film was made in 1910 to celebrate the return of Halley's Comet, only religious mystics thought the sky held any surprises.
A long time ago, it was a flood in Noah's day that wiped out mankind. Now it will be a gigantic fireball.
The world will not end. Certainly these new bodies will pass our planet, but we are still here. Predicting the end of the world is an annual crackpot event in our society, an attempt to corner the newspaper headline.
Massive impacts and catastrophe are in the textbooks, but very much as part of the Earth's early history. Over 4 billion years ago, when the solar system was still forming, there were swarms of large rocks smashing into the Earth. But after 1 billion years of bombardment, these giant asteroids disappeared, leaving the Earth alone, inviolate in space. The meteorites we see nowadays are a pale shadow of those earlier giants. Still, they prove that the space between planets isn't entirely empty.
There's a constant infall of extraterrestrial material. The bulk of this arrives as dust. Hundreds of thousands of tons of material actually falls each year. If that was all to arrive in one go, clearly that would be catastrophic. But this dust falls gently or drifts gently down onto the surface of the Earth. Only very occasionally larger objects, sufficiently large to survive passage through the Earth's atmosphere, land on the surface of the Earth as meteorites.
A gentle rain of dust and pebbles that our atmosphere, like a shield, protects us against. It was a nice, safe picture that is only now being seriously challenged. The scientific doubt started in the 1950s, when the truth about a large hole in Arizona became too big to ignore.
Well, this crater was the first meteorite crater in the world that was shown to be a meteorite crater. So it was extremely important in that first intellectual step to recognize that, yes, indeed, very large objects do fall out of the sky and make holes in the ground.
To help his colleagues with this intellectual step, Shoemaker needed solid scientific evidence.
One was to study the structure, the deformation on the walls of the crater, and how rocks had been pushed out and then peeled up and overturned, and I could compare that deformation directly with experimental craters.
But this crater was geologically very young. Could there actually be larger rocks out there amongst the pebbles and dust? From then on, the Arizona crater became famous as a tourist attraction. To science, it was just a one-off. Shoemaker turned his attention to somewhere where he could study more craters.
Maybe it looks obvious now that the craters on the moon were formed by impact, but in fact, the vast majority of scientists who studied the moon, astronomers in particular, at the time that I began this work, thought that these craters on the moon were probably formed by volcanoes. That had been the prevailing idea for a century before.
The Apollo missions confirmed the violent history of the moon's surface. It also provided Shoemaker with information that lay hidden on Earth.
The beauty of going to the moon is there's no rain, no atmosphere to speak of. And so a crater once formed lasts a very, very long time. So we have a perfect record going back 3 1/3 billion years in which we could say, here is the rate at which these things have been formed, and compare that directly to the Earth.
He found that large craters were still regularly being formed, and so somewhere out there, giant rocks were still threatening Earth.
This is a problem that perhaps is of more interest to a geologist than to an astronomer. Indeed, astronomers in the 20th century essentially abandoned the solar system. Their attention was turned to the stars and the galaxies, and very few were interested in the solar system, in the planets, or specifically in the Earth. The Earth and the moon really ceased to be an object of inquiry for astronomers.
In the early 70s, Shoemaker's attention turned to the apparently empty sky.
Our next step was to see what were the objects that made these craters. The only way to answer that is to go to the telescope and scan a large part of the sky and see what's coming by. This was the first time ever that anyone had attempted to go and systematically survey the space near the Earth
for Earth-crossing bodies, asteroids and comets that could hit the Earth. At the time we started, only slightly more than a dozen of these things had ever been discovered in the entire course of astronomical observation.
This was not surprising, since the rocks he found were tiny by astronomical standards. Faintly reflecting the light of our sun, they could just be picked up on photographs, drifting against the starry background. But the more Shoemaker looked, the more he saw.
This is in the constellation of Scorpio. Dr. Fry, notice the position of these new bodies.
Yes.
Now, just how fast they've been moving and their eventual destination are among the mathematical problems now being determined by our differential analyzer.
Despite their faint image, these were not pebbles. These streaks represented huge mountains of rock weighing millions and millions of tons, all with the potential to hit Earth. While for decades astronomers had been probing the galaxies beyond our solar system, we had ignored what was right under our noses. Belts of rocky debris had long been known to orbit the sun, but none of it was meant to come near Earth. What was going on out there?
Essentially, there are two catastrophic machines in the solar system which are directing missiles at us. One of them is the asteroid belt, which is regularly perturbed by Jupiter in its orbit close to the asteroid belt. And the other one is the so-called Oort cloud, which is perturbed by the galactic environment. Both these sets of perturbations result in asteroids or comets being deflected from their normal places into the center of the solar system, where they may be trapped through further interactions with the circulating planets. And it is the ones that are trapped that are potentially dangerous. We're a kind of target amongst all these bodies milling around which have come from places further out in the solar system.
Over a certain size, the atmosphere no longer shields the Earth's surface from these rocks. For instance, something 100 meters across could easily impact still traveling at 20 kilometers a second. And at that velocity, it would do a lot more than make holes in people's cars. One man who appreciated the destructive potential of these rocks was the Nobel Prize winner Lou Alvarez. In 1980, he and his son Walter were investigating a peculiar event in prehistory. 65 million years ago, over half the world's species disappeared, including the dinosaurs. Alvarez had a vision of what might have caused it, and it certainly wasn't uniform or gradual. Nice idea, but it all smacked of catastrophism, and the reaction of paleontologists was predictable.
I think it was almost universally negative. One can find a few who were not negative, and of course this number increases with hindsight, but no, I think to a first approximation, we all found it an appalling idea.
There were many other more terrestrial explanations for global havoc, such as climatological change or massive volcanic eruptions, none of which required such a gigantic act of God.
Paleontologists are accustomed to think in terms of long-term geologic processes affecting the evolution of life. And if you now suddenly tell them, well, occasionally a stone the size of a mountain falls out of the sky and produces a global catastrophe, they just don't like that. It's against their scientific religion, if you will.
We didn't know anything about what had been learned through the 60s and 70s about meteorite impact and the impact rates, the because we had grown up with our textbooks which said that there indeed were bombarding asteroids and comets, but this was all in the early days, the so-called early bombardment of the Earth, and it was all over. And sure, Meteor Crater was probably an impact crater, but that's only one. It couldn't affect geologic history.
But something killed the dinosaurs, and the Alvarez theory compelled scientists to consider seriously an extraterrestrial force.
It's stimulated much new data, but more importantly, it has put paleontologists in communication with the rest of the scientific community. And so we're interacting with astronomers, with geophysicists, with geochemists. And this is wonderfully stimulating for both sides.
Theories began to fly. If rocks could cause one mass extinction, why not others? Perhaps the Earth was periodically visited by devastating swarms of meteorites. Indeed, the geological records seemed to show there was a regular pattern of extinctions.
So we suggested that extinctions occurred in a clock-like way. That is, not all extinctions, but pulses of extinctions every 26 million years. This we published, and the astronomers, they're a rather gullible group, picked up on this and suggested a wonderful array of possible astronomical, solar system, or galactic explanations.
There were invisible planets, twin stars, galactic clouds, and giant comets, all just theories. But the cataclysmic demise of the dinosaurs captured the public imagination. And after a century of ridicule, catastrophism had something to shout about. Meanwhile, other astronomers had followed Shoemaker and started hunting for the rocks in near space. They joined in the tedious task of searching photographs of the night sky. The discovery rate increased enormously when the system was computerized with CCD cameras, acting like unblinking electronic eyes, and far more sensitive to any movement of these objects. Soon the astronomers were reassessing the size of their task.
In fact, we've only discovered maybe 5% of the total so far, and if we continue at our present rate, it will take us another 500 or 600 years before we discover 99% of them. However, the total number of astronomers involved in looking for Earth-threatening asteroids is in fact less than the staff of something like a high street McDonald's restaurant. Okay? That is the number of people worldwide that we're talking about looking for asteroids.
We know, for example, there are about 2,000 larger than a kilometer, a few 100,000 larger than 100 meters, and 150 million or so larger than 10 meters. But none of this was known just a few decades ago. We're in an age of discovery.
Steve Ostro took the search a step further when he managed to pinpoint one of these mysterious rocks with radio telescopes.
We've never seen an optical picture of any Earth-crossing asteroid. And this is a little bit ironic because we do have pictures of all other classes of major solar system body. The gaseous planets, the solid planets, their moons, ring systems, and main belt asteroids now. But we have no pictures of any Earth-crossing asteroids because we've never sent a spacecraft to any Earth-crossing asteroid.
While some astronomers concentrated on getting pictures of the edge of the universe, this was the first image of our closest companions in space, the faint radar trace of Castelia, a huge dumbbell-shaped rock rolling over and over. 2 years later, he had more warning and captured the near-Earth asteroid Tutatis. At last, these dark monoliths were giving up their secrets.
It's obviously undergone an extraordinary history of collisions for the past, at least 10 million years, several tens of millions of years. It's unlike any other object that we've ever seen. It's highly irregular. It has craters on it. It's jagged. It's in an unusual rotation state, so it's not just spinning around, but it's almost as if it's tumbling. And it's clear that there are a lot of questions about where this object got its unusual properties. Where did it come from? Imagine for a moment if, instead of these objects being tiny and not visible to the naked eye, they were suddenly made visible. Suppose that there was a button you could push and you could light up all the Earth-crossing asteroids larger than about 10 meters. There would be over 100 million of these objects in the sky, and you'd go outside at night, and instead of being able to see a few thousand bright stars, the sky would be filled with millions of these objects, all of which are capable of colliding with the Earth, and all of which are moving on slightly different courses through the sky at slightly different rates.
An image which would have truly terrified ancient societies. But if we do drift through such a swarm of rocks, why doesn't the Earth bear the scars?
Erosion takes its toll. Rain and wind and weathering of the rocks lead to the filling in of craters. Nature abhors craters. She fills them in on the surface rather quickly, so craters disappear. So what we had to look for was the deformation in the rocks, the wound in the earth, as it were, beneath the crater. And now we know how to recognize that. The crater doesn't hold its original shape. The walls collapse downward, the floor comes up. And what we've learned to recognize as an impact structure is a ring structural depression where the rocks have been depressed in a donut-shaped ring. And then there's an uplift in the center.
Geologists have started to recognize craters all over the Earth. Almost 200 have now been identified. Computer modeling and small-scale experiments have confirmed why these wounds run so deep. It's all a question of megatons.
If we get to a really big event, say a 10-kilometer crater, which is still small compared to the biggest, that's equal to the energy of all of the nuclear weapons in the world. If you heap them up in a pile and set them off, 10,000 megatons makes a 10-kilometer crater.
A rock 10 kilometers wide would unleash 1 billion megatons. That sort of shock, even in this nuclear age, is hard to imagine. This was the sort of event that Alvarez suggested could have finished off the dinosaurs. But no one had pinpointed the scar. Just recently, geologists found some telltale signs beneath the Gulf of Mexico. Although now completely invisible on the surface, measuring the density of the rock underneath reveals a 65-million-year-old wound. A huge ringed depression, almost 200 kilometers across.
Finding the big buried crater in Yucatan was a major step because we found the smoking gun. Really, we found the smoking cannon that produced the catastrophe at the end of the Cretaceous.
The environmental shock produced by a large comet or asteroid impact certainly is a good candidate because of simply, if nothing else, because of the energy levels. The debris which would go out from the impact point at ballistic velocities affect all hemispheres at essentially the same time. As to the particular scenarios, I don't think we know enough yet to know whether it was darkness or increase or decrease in temperature. What the killing mechanism actually was is still elusive. If the rocks falling out of the sky could produce one extinction pulse, then I think we must expect, if not assume, that other extinction pulses also have been caused by this mechanism. And as Shoemaker has delightfully pointed out, when we realize that rocks do fall out of the sky on a regular basis, this becomes acceptable in a gradualistic framework because it's part of the Earth's environment which we accept and understand.
The dinosaurs must have been very unlucky. Fortunate indeed that humans have lived in such a safe time.
If we're going to take the case of a global catastrophe, those only occur something like once every 100,000 years, maybe at the outside once every 200,000 years. So that's a very long time scale compared to the human lifetime. However, for these smaller objects, maybe 100-meter fragments of asteroids which mostly blow up in the atmosphere but nevertheless cause widespread devastation underneath, those occur much more frequently. We certainly should be expecting at least one of those to occur over the next 50 or 100 years.
On the whole, people will accept it so long as the timescales between catastrophes are large. That is, for all intents and purposes, we can treat our present time as non-catastrophic. Now, this is really the crux issue. Can you have catastrophes on short time scales?
Maybe an ancient fear of the sky was based on experience. It is difficult to tease out from myth and legend whether chariots of fire were real, but geologists can provide concrete evidence.
In Australia, we have a group of 13 craters that was formed by an impact of a large iron meteorite around about 5,000 years ago. Now, we know that Aborigines were occupying Australia perhaps 40,000 years ago or more. And it is very likely, indeed, that they actually witnessed this impact event. And their local mythology speaks of a very strange event, and they have a local dialect name for these craters, and translated they talk about fire and devil rock, and all of these things tend to point to the fact that these ancient Aborigines actually witnessed the impact.
It is also possible that during the Dark Ages in Europe, the Plains Indians on the Pampas in Argentina were about to experience nature at its most savage. To the northwest, they would have seen a second sun quietly growing. A 200-meter rock had just entered the atmosphere at a very shallow angle. A wall of flame erupted at the point of impact and rolled downrange for hundreds of kilometers, incinerating everything in its path. The only record of this terrible event was discovered 3 years ago by an Argentinian pilot when he spotted these shallow teardrop depressions in the modern Pampas, caused as the asteroid broke and skipped across the Earth's surface. It's now clear what a near miss this 1972 amateur film represents. Had this fireball hit the Earth, it would have exploded with the force of 5 Hiroshima bombs. Fortunately, it grazed the atmosphere and went back out to space. It is this huge destructive potential that has now started to concern some scientists. They argue that although large impacts are very infrequent, when they do occur, they can kill millions, and so, over a long period, present the same risk to the human race as more familiar killers like plane crashes. Latest estimates suggest something only 2 kilometers across could kill 1/4 of the world's population. But in going public with these issues, they face a wall of skepticism journalists have dubbed the giggle factor.
This is not a publicity-seeking campaign. We are completely aware that most of our colleagues ridicule our findings. But believing what we do, we have no choice but to ask for this hearing.
4 years ago, a group of independent scientists in Washington decided to lobby the US government's Space Subcommittee with a position paper, suggesting we ought to have some plan to cope with impacts. Their move was prompted by an event the year before. A rock, the size of an aircraft carrier, passed close to the Earth and was only spotted after it had gone by.
Well, the position paper was very explicit in terms of identifying the potential threat, the frequency of such occurrences in the past. The last major impact was in 1908 in Siberia, and that left huge devastation, although it was not a populated area, but it destroyed forests over hundreds of miles there. And that actually was what we might call an airburst. It didn't actually hit the ground, but exploded before it hit the ground. So obviously it was a matter of some significance. It appears to the members of the committee that this is a reasonable way to demonstrate the utility and the value of systems that we've been funding for some period of time. That includes rocket systems, telescope systems, all of the things that enter into the space program and the military program.
Catch a falling star and put it in your pocket.
Astronomers versus military scientists. At the Defense Research Laboratory at Los Alamos, Greg Canavan had to chair the interception report.
The small asteroid faction.
In space.
Before these asteroid interception workshops, they didn't see the value of that information and they simply threw it away. To a person, they wouldn't look precisely like an explosion, but a sensor, for instance, from a satellite, just sees a bright flash, and that final flash looks very much like a nuclear explosion.
For years, the military had been watching and ignoring bombardment of the outer atmosphere, explosions that their sensors could misinterpret as nuclear airbursts.
Gentlemen, this is a rough design of our ship. Now, instead of taking off in the customary manner straight up, we will conserve fuel by using a mile-long slide to give us impetus.
To nudge billion-ton rocks sideways in space, the designers came up with solar deflectors, neutron bombs, mass drivers, and even antimatter bombs.
Most of the ideas which I've heard put forward in terms of the interception have been truly bizarre. All sorts of really science fiction type ideas, indeed totally fiction ideas, and they don't seem to be based upon the known laws of physics, many of them.
There were a number of them that were criticized as too futuristic, but we tried to include them all in the report because we're talking about a problem that's probably going to have to be worked on a time scale of decades or centuries. And over that sort of a time scale, I think that it's inappropriate to try to screen what fields are going to develop and what fields are not going to develop. I think I would be exhibiting hubris to say that I can pick now the winners and losers in that technological race.
Controversy dogged the report, but then came the comet Swift-Tuttle. This time it missed the Earth by millions of miles, but astronomers calculated on its return in 2126, the comet would pay a much closer visit.
There was an enormous panic when that warning went out. There was real concern that in 100 years, Swift-Tuttle would come back and smack right into the Earth.
After further calculations, the warning proved incorrect. Still, during the hiatus, the interceptor report was finally approved and sent to Washington. One question remained. Would any organization be willing to drive such a futuristic project?
There was a president of America who saw wicked empire. And for the purposes of dealing with this wicked empire, he set up an organization called the SDI, a Star Wars organization.
Daddy, what this Star Wars stuff is all about. He said that right now we can't protect ourselves from nuclear weapons.
Whether or not the Star Wars organization succeeded in doing what it wanted to do, the mere fact of its existence, or potential existence, was enough, apparently, to bring the Cold War to a grinding halt.
My daddy's smart.
This has created a situation where the SDI no longer needs to exist. And I suspect this has been somewhat of an embarrassment to the SDI. And inevitably, they were bound to look for a way of preserving themselves.
Well, I'm not sure I ought to comment on that. I think the Ballistic Missile Defense Office is probably in a declining mode, but if there is any one office that has the technical capabilities to participate in this program, it would be that office. And I would be delighted to assign that responsibility to them.
The asteroid collision hazard is a tiny little risk compared to the risk to civilization, the risk to the species that we confront overall. There's the population explosion. There's the possibility of eco-catastrophe, global warming, poisoning of the biosphere. We're facing in the next century much more serious risks than asteroids colliding with the Earth.
It looks like previous species have, at intervals of some tens or hundreds of millions of years, have been wiped out by such impacts. They didn't have the opportunity or the means to do anything to prevent such impacts. We do. It's analogous to the hazard of fire to your house. We are currently without fire insurance, and worse than that, we're locked in our house.
Last month, the new Ballistic Missile Defense Organization started to take out that policy. They launched the satellite Clementine. Part of its journey will take it past the craggy rock Geographos, the first ever encounter with a near-Earth asteroid. But the reasons are purely military.
It's to test a whole series of very small, beautiful, lightweight cameras that were designed for detecting missiles. And this is a test flight for those cameras. Now, the science is coming as a gift. It's free, virtually. So so it's a great thing for us.
As the reborn Star Wars organization gathers more information on Geographos, it'll become the natural choice should the world decide to invest in global protection. Meanwhile, closer encounters with asteroids are planned.
Then the next step would be to have hard landings on the asteroids. That is, simply crash into them and see how much blow-off was produced, how much material was expelled, and how large of a recoil was produced, and measure directly how much fragmentation there was of the asteroid.
Well, if we have a standing asteroid deflection capability, then maybe someday people will start trying to deflect objects that are non-threatening into collision course with the Earth. This is intrinsically an extraordinarily dangerous technology. Moving a several kilometer object into collision course with the Earth would be equivalent to engineering a Cretaceous tertiary extinction, a mass extinction. If it's such a dangerous technology and it would be extremely expensive, why in the world would we as a civilization want to do this unless there were a crying need to do it? It just makes no sense.
The only way we can be sure of the risk is to reverse decades of neglect and spend more time hunting and tracking these rocks. NASA has just initiated a $150 million project which will send a satellite into orbit round the giant near-Earth asteroid Eros. A very delicate maneuver, considering how difficult it is to predict exactly where these objects are. As if Newton's clockwork solar system hadn't received enough knocks, scientists have found chaos in the mechanism. It turns out that the orbits of these objects are not as predictable as was thought. So once they have been found, astronomers have to keep a regular eye on them, or who knows where they will end up.
We have lived on Earth such a tiny fraction of the history of the Earth. And the processes, the phenomena that affect the Earth are episodic, they're spasmodic. They don't all occur within the, let's say, 200 or even 2,000 year interval that we've had a chance to observe. And so the greatest likelihood is that we have only seen a fraction, a small fraction of what the Earth can throw at us, figuratively speaking. So I think it is arrogant and unwise for us to think that we really understand the future, because we've had such a small sample.
It has become very clear that all the planets, and the Earth in particular, are in a catastrophic environment. And so Huxley was wrong. It's as simple as that, but he managed, with the aid of many other experts, to convince us all that the world was truly uniformitarian and we were basically safe. We have a great deal of new thinking to go in for now.
Next summer, there is an impact due, but not on Earth. Instead, Jupiter is the target. Last time, the comet Shoemaker-Levy 9 passed the planet. Gravity ripped it to shreds. And next July, a string of glowing mountains will pile into the planet.
That will focus attention on it, and the public will say, well, if it can happen to Jupiter, could it happen here? My guess is that it will produce an increase in enlightened interest in both science and in the possible future of the solar system.
The planet Jupiter is actually going to explode. The consequences will be far more serious than astronomers and scientists are admitting at the moment. Everyone should be warned to buy very dark sunglasses and wear them as I am wearing them now. People should stay indoors, keep pets indoors. Farmers should take precautions to put their livestock, cows, sheep, horses into sheds. Aeroplanes.
If you'd like an illustrated booklet of this programme, then send a cheque for £3 made payable to BBC Education 2, Horizon